Here are some conceptual Taylor polynomial examples. The first one gives you a function f, gives you some information about the value of f and its derivatives. And first I ask you to write the third degree polynomial, and then we're going to use it to approximate 2.9, f of 2.9. So it works the same as all the others. A third degree polynomial for the function f, or any function f, is about x equals 3 is f of 3 plus f prime of 3 times x minus 3 plus f double prime 3 over 2 factorial times x minus 3 squared. And finally, plus f triple prime of 3 over 3 factorial times x minus 3 to the third. So you can see this derivative that looks like it's just extra. We're not going to need it. So fill in all the values. P of x equals f of 3 is 3. F prime of 3 is negative 2. F double prime of 3 is 2. And 2 factorial is 1 times 2, which is 2. And F triple prime of 3 is 4 over 3 factorial, which is 1 times 2 times 3, which is 6. So here's our Taylor polynomial. 3 plus negative 2 times x plus 3 plus 4x minus 3 squared. This is minus plus 2/3 x minus 3. So we've just answered the first question. Next task is to use this to approximate f of 2.9. So we're not given f, but we do now have a good approximation. So f of 2.9 would be approximately equal to p 2.9, which actually equals 3 plus negative 2 times negative 0.1 plus negative 0.1 squared plus 2/3 times a negative 0.1 to the third. Grab the calculator, type that out. So according to my calculator, if I didn't screw it up at all, the answer is 3.209. That's it. Those are actually easier than the ones that you're given the actual function, because you don't have to worry about calculating the derivative, obviously. So I want to look at, that was pretty short, so let's look at one last example. This is a little different. So this gives us the Taylor polynomial for a certain function f, and it wants us to figure out what the value of the fourth derivative at 2 is. So now we're kind of working backwards. So to take on this problem, first of all, for any Taylor polynomial, the fourth derivative would be part of the term that has the x to the fourth term. So that's what we're going to focus on. That term in any Taylor polynomial about x equals 2 would be this term. Fourth derivative at 2 over 4 factorial times x minus 2 to the fourth. So that's generally always that term for any Taylor polynomial centered about x equals 2. So our Taylor polynomial, we have to look for that term. So we don't have to worry about any of this. We're only concerned about this term, the one that has x to the fourth. So we know this term had to have been created by that, I guess, formula, we'll call it. So this would be equal to 7 times x minus 2 to the fourth. So now from there, you just figure out what f, the fourth derivative of f of 2 is. You could do this algebraically by dividing by x minus 2 to the fourth if you want to get rid of that. Or you can just say, we know the coefficient, the constant term would be that has to match that. So I'm going to say fourth derivative 2 over 4 factorial must equal 7. I'm going to multiply both sides by 4 factorial, which is 4 times 3 times 2 times 1. We get, so we get 7 times 4 is 28. Times 6. 6 times 8 is 42. 12 plus 4 is 16. So that is the fourth derivative of that at x equals 2. And that's what the question was. So that's it. Use these videos to help you along with the quiz preview. And then obviously to use that to help you along with the quiz. You should be okay. If you have any questions, as always, please let me know.